Hi friends, here in this video I'll be explaining the problem on epicyclic gear train. So let's get started. Now here is the question in front of us. Whatever is given here, I'll write that in the form of data. It is given, figure shows a compound epicyclic gear train. So we have the type of gear train written. Then wheels A, D and E are free to rotate about point O. So here there is point O about which A, this annular wheel D and annular wheel E are rotating. So they are having the same common center, that is point A. Next, wheel A has 12 teeth. So number of teeth on A is 12. B has 30 teeth. C has 14 teeth. Find the speed of wheel E. It means here the question is we have to find the speed of this annular wheel E, denoted by N suffix E, and arm OP. So we have to also find the speed of this arm OP, which would be rotating, N suffix OP. Then if A rotates at 1 RPS, so the direction of rotation is given clockwise and it is in revolutions per second, speed of A, 1 revolution per second in the clockwise manner. So multiplying with 60 will give me the answer in terms of RPM, because I would be finding all the speeds in terms of RPM. So it is 60 RPM in the clockwise sense, hence it is positive. Then D rotates at 5 RPS in an anti-clockwise sense, it is given here by this symbol. So it is minus speed of D minus 5 RPS due to its anti-clockwise nature. So converting it into RPM by multiplying with 60. So speed of D comes out to be minus 300 RPM. This is the value which we'll use in the problem. Then also when we look into the diagram, I'll quickly explain what is given here. This gear A is having center O, it is rotating about the center. Now A is in mesh with gear B, as we can see here, and A and B, they are external gears. Then B is in mesh with outer annular wheel A, outer annular wheel E, they are in mesh. At the same time, we can see B and C, these two gears are on the same shaft and they would be rotating about this common point P. So C is an external gear and it is connected to this another annular, which is annular D, which is also an internal gear. Remember, both the annular E and D, they are internal gears. So at first, by looking into this problem, this is a problem of epicyclic gear train, and B and C, since we are having two gears mounted onto the same shaft, they are called as compound gears. So it becomes epicyclic compound gear train problem. Now whenever we have such cases or such problems, the first thing we should do is to find the number of teeth on all the wheels. And when we look into the data which is given to us, we have number of teeth on A, B and C. It means we have to find out the number of teeth on wheel D, that is the unknown, and the number of teeth on wheel E. So at first I would be finding these number of teeth and then we would go into the further part of the problem. So let's get started with the solution part. Now in the solution, I'll use the concept of geometry, that is since from the geometry of the given system, first I would be going for the calculation of number of teeth for annular D that I am going to find. And now I can see that from this center up to the internal radius, or we can say this is the internal radius for the annular D, that is up to the center. I'll just show it over here. the radius of this annular D. Now this small radius is made up of radius of A, as we can see here, radius of A, plus it is also made up of, on one side we have radius of B plus the radius of C. I'll explain it again, that we have to find out the radius of D, and radius of D is made up of radius of A, wheel A, plus the radius of wheel B, and from this center up till here the radius of wheel C. So RD is made up of RA plus RB plus RC. Next, writing all the radiuses in the form of diameter. So it is diameter by 2. Now since we know that module is pitch circle diameter divided by the number of teeth, so therefore diameter is module into number of teeth. So here I would be replacing all the diameters with m into t, that is module into number of teeth, first for wheel D. And also I can say that 2 is common in all the elements, so it gets cancelled out, is equal to, here we have m into TA plus m into TB plus m into TC. And for gears in mesh, gears to be in mesh, the module should be same, so module gets cancelled, and what remains here is TD is equal to TA plus TB plus TC. So therefore TD would be, the value of number of teeth on A is given, it is 12, on B it is 30, and on C it is 14. Adding up all the values will give me the answer of number of teeth on annular D as 56. So that is the number of teeth on wheel D. Similarly, I would be calculating for E. From the same center up to the outer radius is the radius of wheel E. This radius is made up of, it can be clearly seen with radius A plus, here we have diameter of B, that is the bigger wheel. So it can be written as similarly radius of E is equal to radius of A plus diameter of B. So therefore, again writing the radius in the form of diameter, so it is diameter by 2. And also for this case, since the module is diameter by number of teeth, so therefore diameter becomes module into number of teeth for wheel E. Module is same on all sides, it gets cancelled, so we have TE by 2 is equal to TA by 2 plus TB. Therefore TA is given, it is 12 plus TB 30. On calculating, I am getting TE value as 72. Now after getting the number of teeth, in the question when we see there are two things asked, we have to find the speed of annular wheel E and the speed of this arm OP. And for that I would be using the tabular method, and I am explaining it now. First I'll draw the table. So here the first column is for the number of steps, then for the operations. Next, whenever we have the problem on epicyclic gear train, and in that when we have this arm, so the column should be for the arm first, and this is arm OP. Then the speed of rotation of A is given, so I would be starting it with after the arm A is rotated, so speed of gear A. So we have gear A. Then A is in mesh with B, gear B, and as we can see, B and C, they are compounded, so whatever is the speed of gear B, same will be the speed of gear C, because they are on the same shaft, they are compound wheels. So B and C having same speed. Next, B, we can see it is in mesh with E, and C is in mesh with D. So after C, gear D, and then at last gear E, which is in mesh with B. Now, how to start this table is, in the operations part, fix the arm OP and give +1 revolution to gear A. So when I keep the arm OP as fixed, its speed is 0, +1 revolution is given to A, and for gear B, I am going to find its speed by using the velocity ratio concept. Since for two gears in mesh, the velocity ratio formula is given by speed of the driven gear, and when we look into the diagram, A is driving gear B, so A is the driving gear, B is the driven gear. Speed of driven upon speed of driver is equal to number of teeth on driver upon number of teeth on driven, and since A and B are external gears, so if A rotates in a clockwise manner, B would be rotating in an anti-clockwise sense, and as the sense is opposite, so we have to introduce a negative sign here. So therefore NB is equal to minus NA gets multiplied, and here we have TA by TB. So therefore NA is 1, because we have assumed that we are giving +1 revolution to A. Minus TA by TB is the speed of gear B. I'll write it into the table here. And since the speed of B and C are same, so NB is equal to NC, because they are compound gears mounted on the same shaft having the same speed. Next, while looking into the figure, as we see, C is in mesh with D, so the next velocity ratio would be between C and D. Since B is rotating in an anti-clockwise manner, even C would be rotated in the same direction, because they are onto the same shaft in an anti-clockwise manner. When C rotates anti-clockwise, even D would be rotating anti-clockwise, because C and D, they are connected in such a way, like D is the internal gear, so when C rotates anti-clockwise, even D would be rotating anti-clockwise, and the direction of rotation is same for C and D, so the velocity ratio has to be positive. So therefore velocity ratio between C and D is the driven, so its speed would be there in the numerator, upon speed of driver, which is C, is equal to the number of teeth on C upon the number of teeth on D, inverse proportion. Here there is no negative sign because the sense of rotation is same. We are not taking here anti-clockwise as negative. We have to remember that while finding the velocity ratio, we have to see that the sense of rotation is either same or opposite. If there is external gear, then the sense of rotation is opposite, so we have to take negative sign. Whereas when we have two internal gears, when we have an internal gear which is in mesh with an external gear, the direction of rotation is same, so there would be a positive sign. So therefore, ND will be equal to NC into TC by TD. NC value, I'm going to put it the same value as NB because they are same, mounted on the same shaft. This speed, I'll put it into the table for D. At last for gear E which is the outer annular, it is in mesh with B as we can see here. So B is the driving gear and E is the driven gear, and their sense of rotation are also same because of E being an internal gear. So therefore, similarly, E is the driven gear, B is the driving gear. So speed of driven upon speed of driver, sense of rotation is same. So TB upon TE is positive value, and therefore NE will be NB into TB by TE. So NB, the value we have here, which is minus TA by TB into TB upon TE. TB and TB gets cancelled. So what remains here is NE is equal to minus TA by TE. After completing this first step, the next step is multiplying by small m, which is RPM throughout. So m into 0 is 0, so m into 1, that is plus m. Next, the next step is adding plus n revolutions to all elements. So n plus 0 is n. Here we have m plus n. Then the last step is total motion. In the total motion for arm OP we have n, for gear A m plus n. Similarly for the remaining gears. So in the total motion we are getting the speed of all the elements, starting with arm OP. This is the speed of arm OP. Then gear A, B and C are same. Then gear D. Last gear E. So these are the speeds which we have to use. Since we have to find the speed of the annular, so here I'll explain the conditions. The first condition which they have given is speed of gear A is 60 rpm clockwise. So I'll use that. That's since (60 rpm clockwise). Therefore, from the table, A is having the speed which is m plus n, so equating this m plus n which is equal to na from the table, so therefore m plus n is equal to na is 60. The first equation. Next condition which they have given is gear D rotating at minus 300 rpm anti-clockwise sense. ND, I'll get it from the table. It is this velocity ratio. I'll write it. This is the velocity or the RPM. I'll write it here. So putting the respective values, minus M, TA into TC. TA is 12, TC 14, TB is 30, TD we have found out, it was 56. So when I calculate this term, the coefficient comes out to be minus, it is 0.1 m plus n is equal to minus 300. That becomes the second equation. So we have two equations and two unknowns that are m and n. So solving, equations 1 and 2 simultaneously, we get the answers as m is 327.27 rpm and small n is minus 267.27 rpm. Their units are in rpm, remember. Now after getting m and n, see n was basically, I'll explain it with the help of the table. Small n was the speed of OP and OP is the arm when I look into the diagram. So one of the question was to get the RPM of this arm OP. So the first question has been answered, that is small n indicates the speed of arm OP, which is 267.27 rpm, and it is rotating in an anti-clockwise sense because the answer is negative. So that's the first answer which we have got. It means whatever the arrangements and under the given conditions, this arm OP would be rotating in an anti-clockwise manner, having a speed of 267.27 rpm. Similarly, I'll get the speed of the annular wheel E, which has been asked. So therefore, NE from the table, it is minus MTA by TE plus N. M value is 327.27 and here we have negative sign. TA is 12. TE came out to be 72. We had calculated it. Then plus N value is negative minus 267.27. Therefore, speed of wheel E comes out to be minus 321.82 rpm or 321.82 rpm in an anti-clockwise sense because of the answer being negative. So that's the speed of wheel E. Second answer, it means under the given conditions, wheel E would also be rotating in an anti-clockwise manner and it has a speed of 321.82 RPM. Now when I look into the question, both the questions have been answered, and with that the problem on epicyclic gear train gets completed. At the end, if you all find my videos helpful, you all can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.